Hey, welcome back to Centerline Designs, everyone. My name's Cole if you're new to the channel, and in today's video we have a custom customer's project to do today, and this is an all-aluminum kayak lift that lowers and raises a kayak into the water. The base mounts to a floating dock, and it also allows you to rotate the kayak around for storage on the dock itself. That then leaves the face of the dock free to park a boat at. This was something that we designed together, me and the customer, and it's a pretty interesting project, so stay tuned and let's get to work. I think we're gonna get started squaring off the ends of this 4-inch UHMW round, because this is gonna be the material that is the sleeve bushing between the moving cradle section and the stationary post that supports all of this kayak lift. So we'll get this squared off in the bandsaw, head over to the lathe and get this roughed out to size, and then it's going to be pressed into this once some tabs get welded on. Let's get over to the bandsaw. The blade on that bandsaw is just a little too fine to cut this UHMW very nicely, but this dry cut saw will take it off. A nice square edge to get started with. So this looks like a crazy amount of stick out because it is. I'm gonna see if we can get it spinning true enough to get a center in the end, and then we'll support the end with the tailstock live center. We'll do all the machining for the OD, or close to it, with a little bit extra. This is much longer than I needed. I had to buy it by the foot and I only needed 6 inches. But we'll keep a little bit on that we can grab with the chuck when it's all said and done, and then we'll drill it out and bore it out after. It gets a little interesting to work with because it is such a soft material. When we get to a fairly thin wall, it's hard to hold on to it because it just wants to slip out. So hopefully we'll get there. I'm pretty sure I've done a little bit of work like this with plastics before, and it's nice material to work with because you can just hog it off. But we'll see how this goes. I'd say that's pretty true. I guess we should figure out what dimension we're gonna need on the OD of that plastic. And we are looking at about 3.59, 3.57. We're gonna give this a pretty good interference fit so that we have to press the UHMW sleeve in. So I'll probably go maybe 5 thou, maybe even 10 thou. We'll see how that works oversized. We'll have the ID bored out close. We'll press it in, which is gonna shrink that plastic down, and then we'll bore the ID of that out after to fit our pipe, our post. That's gonna leave us with the best way. So it's gonna be a press fit, and then we're also gonna put some fasteners in very shallow depth that bite into the sleeve so it can't slip out while it's going up and down. Let's get machining. go cut it down. See, that's what happens. Kind of as expected, I was having a lot of trouble holding on to this slippery plastic. There's a lot of stick out there, and I don't have a steady rest, but even if I did, I don't think there's room on the lathe to give it any extra support. So I did what I could. The OD is at approximate dimension. I think it's close enough. What my backup plan is gonna be here is we're gonna go ahead and press it into the aluminum and do all the final internal machining after. I hope to bore it out a little more to allow it to compress down easier, but I think we'll get it. I'm just gonna go throw an internal chamfer on either ends of this. But before we press this on, there's some welding and drilling and tapping that needs to happen on this piece. So we're gonna have to take care of that first. You know, I try one thing and the order of operations just needs to change a little bit. So we'll get that done. We'll get some pieces cut, drilled, welded on, and then we'll press this plastic in. And then once it's pressed in, we should be able to hold this a lot better, and it'll be more support, and then we can bore it out to sleeve on our post. have our temporary spacer in between the two flanges here that we're going to weld on to the moving sleeve. I think it's all set up. I wire brushed it, acetoned it. Let's get to some aluminum TIG welding. Well, that welded in quite nicely. Now we just got to let that cool down and press the plastic in. There we go. It's completely pressed in. Now we can chuck this up on the lathe and start some of our machining work. All right, well, we're definitely running into sketchy territory, but clearance is clearance, and it works. We knocked out the rest of it. I had to do 5 inches from one end and then 1 inch from the other. And it's a rough finish, but this isn't high tolerance. That's gonna sit there. And then this will slide up and down. Perfect. Well, I'm happy with that. Let's make up the screws and put the set screws in here. These set screws should just bite into that plastic just a little bit and keep it from ever popping out. I do have some very rough hand drawings that I did when we designed this with the customer. With this component, which was probably the majority of the work, honestly, with the machining and welding and that kind of stuff. Now we need to cut out the base plate, so we're going to set up some sawhorses and cut up some 3/16 50/52 aluminum that the post will mount to, some bracing, and then we'll mount the winch on top and build a cradle. Well, I'm back at this another day, and since we have the moving sleeve for the kind of carriage assembly done, it's time to work on the base plate. And we have this piece of 3/16 aluminum cutout. This is a Schedule 80 2.5 inch pipe, aluminum pipe. That needs to get mounted vertically on here with a bunch of bracing, and this is going to be bolted down to a floating dock. The idea here, if I haven't mentioned, is that nothing hangs over the edge of the dock, so a boat can still be parked there, but this will secure down to the dock face and bite into the structure. And it's time to get cutting up some more material, and we'll get welding on the bracing on. with the topside bracing welded on, we need to put 2 strips of flat bar on edge on the underside, and it's going to straddle a 2x6 decking board, and that flat bar on edge is going to help give more rigidity to this flat piece of plate and transfer some of the forces from that topside bracing through the entirety of the plate. I think it's going to help keep some rigidity in the system without having to have been thicker on this base plate. Could have gone thicker on the base plate, but it would have been, something more to stub the ball of your foot on. So we went thin, and I said, let's just put some flat bar in there. It'll straddle the 2x6, even if you have to take a skill saw or a circular saw and cut a little bit of more of a slot between the deck boards. It's a good way of adding bracing without interfering with it being a walkway. So we're gonna get some strips of flat bar cut up and welded on. With the base of this all cooled off from all that welding, it's mighty sturdy, so we need to work on the mount for the winch, and I have a piece of mild steel round stock here, and that's going to act like a slug that sleeves into this pipe, and then we'll put 4 bolts in to hold it. And I'm doing it this way so that if this ever needs to come off for repair or something, we can pull those bolts, pull the winch off, and this sleeve can come off, so it can be disassembled. If we do any other kind of welding of a plate or something on the top, that's on there for good. So we just need to put this slug in the lathe, face it off, and mark our holes, drill, and tap on this, and then we'll get the winch mounted. Okay, let's test fit this. Nice. Looks like the other 4 holes line up. It's nice and flush. Perfect. Let's get a piece of plastic cut and the winch mounted onto this.
That's so cool.
Yeah, you like that? Whoopsie. Alrighty, well, if you haven't already put it together, you'll see we have that slug that we machined that fits in the tube. That's actually really gonna help with the leverage, and these bolts are acting on shear, so that's gonna be plenty strong enough. I quickly off camera cut a disc of UHMW out of the same material we made for the sleeve, and we obviously drilled a 1/2-inch hole in there. That'll go on there, and then the winch will sit on top of that, and we'll use a nylon bolt, tighten all those things together, maybe even put a little bit of Loctite in there, and that's gonna allow the winch to spin around on the top of the post as the carriage comes up and spins over on the dock. I think it will work pretty good. Again, we're lifting like a 150-pound kayak. I'm probably way overbuilding this, but I really don't want it to break for the customer. So let's bolt this up and get it mounted on the post and see what it looks like. Oh yeah. So once we have a longer bolt in there and I can engage the nylon portion of the nylon lock nut, we can kind of just set the tension on this nicely. And if it ever needs to be adjusted, it won't be too hard since we have these removable kind of set screw bolts. But that's the idea. There'll be a cable that comes off there, attaches to this carriage, and lower it down, lift it up. Awesome. Well, this cable is probably a bit too large because it just wants to bird cage up without any tension on it. So we might have to revisit this cable diameter and go to something lighter, but for now, let's see how it does. We'll get a hole drilled in this moving sleeve and hook it up. Well, I'm really impressed with that. It's coming together. This is gonna be its first test. We'll stand on here to simulate it bolted down. And then when you swing the kayak around, this can follow. And then lower it down. Swing everything. So it'll drop it down into the water, pick it up, swing it over to the dock, set it down. Yes. All right, well, let's consult the very crude drawings. And if you can make anything of that, I need one piece at 40 inches. We're gonna use some 3/16 material for the vertical section to keep it from bowing with the cantilevered weight on it. And then we have some 1/8 square tubing for the remainder of the pieces. And yeah, let's get cutting. Too shabby. If you're new to fabricating, what I like to do is tack all 4 corners first, make sure you're square and parallel, and then go ahead and weld the flats. If you weld the inside corners first, it's gonna pull out a square much worse for you. So I like to go ahead, after all 4 corners are tacked, we weld one flat, we weld the other flat, and then when we go and weld the inside corners, we have that long weld on either side that keeps your tubings or whatever you're doing from pulling in or pulling out or twisting, and all metals are gonna shrink as that weld puddle cools down. And you'll notice it with steel, and it's worse with aluminum. And that's just the best way I've found to keep things square, and you've got to think about where you weld and when, and you can save yourself some headache down the road. Just a little tip for you. There we go. Let's mount the, I don't know, carriage, whatever you want to call it. I think that looks really good. Let's give it a test. I think that works perfect. All we gotta do is cut a couple little brackets and then put 2 pieces of treated 2x4 as the bunks that the hull of the kayak will sit in. And I'm gonna bolt those on just in case the customer wants to move them around a little bit. If I weld them, they're fixed. So this way, if he needs to make any fine adjustments, he can do that without having to get me involved. So let's cut a couple pieces of metal and then cut some 2x4 and bolt it all together. All right, these are gonna mount like this. All we gotta do is mark the hole. All right, well, I think I can say that this is probably a success. It sure feels pretty good. It's taken my weight, and I weigh more than that kayak. I'm not gonna be able to check it with the actual kayak right now. I don't have it, the customer does, so we'll have to wait to hear back from him. But there we go. Everything spins around. Well, that was a little bit of a unique build. We did some machining, welding, cutting, drilling, tapping, you name it. There are gonna be some things I need to address. That main stud bolt that's holding the winch down, like I say, I need to go get a slightly longer one and I'll replace that. And then that winch cable, obviously I knew it was overkill. I just bought it because it had a pre-crimped clevis or clasp on it. And I think it's way too big. It just wants to bird cage and spool up. So I'll look at maybe going with a 1/4 inch cable, or even rope would probably be fine, a really good quality rope. But I'll talk with the customer about that. I'll let him know. He is a family friend, so he'll get it. And we'll make whatever changes we need, but for all intents and purposes, I'm gonna call this thing done. I'm really happy. I think that worked really well. I've shown him some pictures. The customer is very impressed. So let's leave that video there. And thanks everyone for watching. I hope you enjoy these kind of custom projects. This was designed by me and the customer, and I think it went really well. So that's always a bonus. We'll see you in the next one. Cheers.